Hello everyone, welcome to the Mathematics MI channel. In this video, we are going to solve this awesome integral from 0 to 1, x to the x raised to the x to the x raised to the x to the x, and this is going to infinity. Well, how to begin? Okay, first I'm going to take this part is equal to y. So y is equal to x to the x raised to the x to the x raised to the x to the x, so on. So we know y. Also we can write y is equal to x to the x raised to the, now this part also we know is equal to y. So here y. Now if we take natural log both side, here we have natural log of y is equal to, now according to property of natural log, this y we can write here y times natural log of x to the x. Well, then as a next step, natural log of y is equal to, now y we can write, we can express by using e exponential. So here e to the natural log of y times natural log of x to the x. Okay, then here I'm going to isolate the natural log of x to the x. So natural log of x to the x is equal to e to the minus natural log of y times natural log of y. Then I'm going to multiply both sides by minus sign. So minus natural log of x to the x is equal to minus e to the minus natural log of y times natural log of y. I multiply both sides by minus sign because now I'm going to use the Lambert W function. Now if we have, f of x is equal to x ex, so w of x is equal to inverse of f of x. Also we have Lambert W function, w of x times e to the w of x is equal to x. Then if we we can write e to the minus w of x is equal to w of x over x. So then here we can take both side w. So we can write w of minus, here I'm going to write this side first. So minus e to the minus natural log of y times natural log of y is equal to w of minus natural log of x to the x. Well, now we can isolate the y. So y is equal to w of minus natural log of x to the x over minus natural log of x to the x. Okay, then our integral I here. Now we can write I is equal to, we know y, so I is equal to integral from 0 to 1. Now y, so y here we have, so we have w of, now minus natural log of here x to the x. So according to property of natural log, this x we can write in front of natural log. So we have w of minus x times natural log of x over, here same as the numerator, here also we have minus x times natural log of x dx. Well, then I think you know about the series representation of Lambert W function. W of z is equal to infinite series, n is equal 1 to infinity minus 1 to the n minus 1 over n factorial times z to the n. So therefore we can write our integral is equal to integral from 0 to 1 sum of n is equal 1 to infinity. Now minus 1 to the n minus 1, here also we have minus sign, here also minus 1, so we have minus 1 to the 2 times n times n to the minus 1 plus n, so n to the n minus 1, then x to the n minus 1. Here also we have x. So then here natural log of x raised to the again n minus 1 over n factorial here dx. Well, let us simplify a little bit. So here now we can interchange the sum and integral sign. So n is equal 1 to infinity, here minus 1 to the 2n, now here n to the n minus 1 over n factorial. Now integral from 0 to 1, here x natural log of x, so x times natural log of x raised to the n minus 1 dx. So this integral we solved in a previous video. So integral from 0 to 1 x times natural log of x raised to the n power of dx is equal to minus 1 to the n times n factorial over n plus 1 raised to the n plus 1. So if you like to watch this video, I will add the link in the description. So now here we have same integral, but instead of n, here we have n minus 1. So we know now our integral is equal to sum of n is equal 1 to infinity minus 1 raised to the 2n times n raised to the n minus 1 over here n factorial. N factorial we can write n times n minus 1 factorial times now here minus 1 to the, now instead of n we have n minus 1, so n minus 1, then here again n minus 1 factorial over n to the n. So we know we can simplify n minus 1 factorial get cancelled, n to the n also get cancelled, so 1 over n. So we have sum of n is equal 1 to infinity minus 1 to the 3 times n minus 1 over n square. Now we know this is just eta function, so you can use Dirichlet eta function. So this is just eta of 2. Now I think I will remember the value of eta of 2. If not, you can use the relation between eta function and Riemann zeta function. So this is just equal to 5 square over 12. Okay, this is the answer for this integral. If you like this type of videos, please subscribe this channel. Thank you for watching.